second. One second, let me close the unnecessary stuff. And these ones also. Okay. So as we have seen yesterday, MapReduce word count example, how to write a mapper class, how to write a reducer class, and how to write a driver class. And using the help of Hadoop MapReduce Eclipse plugin as well. We have seen that plugin also, and I uploaded that into your Google Drive. Okay. I hope everybody was able to download that and set up in your laptops and run that example. Okay. So word count example, we ran on the cluster. We have seen the output directory and verified the results as well there. Okay. So even in that, in the MapReduce job, we didn't see all the messages. We didn't go through all the messages, but just we observed the statuses. Map 0%, reduce 0%. Map 100%, reduce 0% kind of stuff. Okay. So mainly inside a mapper class, inside mapper or reducer class. So what are the methods that will be present? So setup, map, cleanup, and run. So this is where your actual execution will start, and run will actually call setup method only once, and map method for every key value pair. That means for every input record. So this map method will get called. So that means if you have 1 million records in your input file, so this map method will get called 1 million times. But setup method only once, and even the cleanup method only once. And typically, in most of our MapReduce programs, we will be overriding only the map method. Remaining methods will keep it as it is, because the parent class, the default parent mapper class setup and cleanup implementations are sufficient even in most of our MapReduce jobs. Okay, so that's the gist of yesterday's class. So now I asked about the assignment. Give me a second. This is closed. Yeah, I asked about the assignments from everyone. So I saw some responses also. At least I want to see some observations. Hadoop MapReduce assignment. Okay, let that get loaded. Then we'll see that. Meanwhile, let me start with the loader quick start view. Yeah. Seems like a bit slow today, my laptop. Okay, set up Eclipse with MapReduce plugin and write mapper or reducer and driver classes. Yes, you have set it up correctly. You can see the MapReduce there. You have written mapper, have written the reducer part of it. So val.get underscore key, new iterable of sum, and driver. You could have specified the job name also. You left that job name as it is. So you have written this under training package. So that's why you can see the full class, full package name dot class name dot class. So output key classes, wait for completion. So you're running this. Are you running this on Ubuntu machines?
Yes. No, in quick start VM.
Oh, the color.
I have changed it.
Oh, okay. 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 So this is your vehicle tickets.txt. And what is the delimiter comma? So you have taken the comma delimiter and taking the every word and iterable of 1. Okay. So run the word count MapReduce job on 1 GB size text file, capture the below statistic. So how much time it took?
9 minutes, 56 seconds something.
Okay. So killed map.
It was a 1.5 GB file actually.
1.5 GB file. So that's why I think you have around 13 blocks.
Did you say 10 minutes?
Yeah, it's 9 minutes, 56 seconds.
Wow, that's pretty good. Mine took about 2 hours, but anyway, good.
So it's actually a 1.5 GB file. That means almost like 12 blocks. 12 blocks were there and 12 maps should have run. So there is one extra because one of the map tasks got failed in the middle. So if
Yeah, okay.
Here, let me.
First time when I was running, even I faced that. Like it was so slow. Then I updated my thing from 8 GB to 12 GB. Then it ran fast.
Oh, okay.
Not 4 GB to 8 GB, I guess. I have updated. Sorry.
Oh, you had that leverage to good, okay. Yeah.
Okay. So here you can see how many input records were there fed into map and how many output records were written from mapper class. Okay. And also the total number of map tasks.
Shiva, can you go one slide up? I have a doubt over there. I just wanted to ask, so that's the reason why I kept all this.
Okay.
The map job was not 100%, but the reducer picked up at 57% of map.
Yeah, I will show you this. I will explain you this. This is due to before all the 12 map tasks, you have 12 map tasks completed, right?
Yeah.
Before, assume before the completion of 12th map task, already 11 or 10 are completed, right? So from those map tasks, you will have intermediate output data generated.
Okay.
That intermediate output will get copied onto some reducer nodes wherever your reducer task is running. So the copy process need not to wait until the completion of the 12th map task. Okay. So that's the reason. Edged map outputs. Reduce input records. Map input records, map output. So job counters, MapReduce framework, fine. Total launched, spilled, shuffled maps 12, merged map outputs 12. Okay. So in part R file.
See, I got only one part R file and only one reducer was running.
Only one reducer was running. That's the reason why it took a lot of time. And even here, so if you observe here, I don't see the reducer jobs. Reduce shuffle.
It's your.
Did you put something here?
What?
I mean,
See, your launch map task, launch reducer task.
Okay. Okay. So launched map task 13 and launched reduce tasks 1.
Yeah.
Okay. Yes, this is what I was looking for. So only one reduce task is running, and even in case, so why it took that much of time, there is only one map task or two map tasks might be parallelly running. Okay.
Yeah.
So
I got that though. To ask those only I kept all the screens.
Yeah. So if you run your MapReduce job and when you don't have that much of RAM memory available in your systems, so what it will do is it will only spawn a one map task, and once after that map task is completed, the second map task and third map task sequentially. When you don't have such configuration, if you already have enough RAM or enough resources.
Actually, Shiva, when I wrote in the code, like I want 3 reducers, it ran with 3 reducers.
If you specify there in the MapReduce job, it will.
In the driver code,
In the driver code, there is a method to specify the number of reducer tasks. If you specify that, it will run those many number of reducers. If you don't specify, with the default configuration, it will run only one reduce task, and you can change that in the cluster wise. There is number of reducers determination formula is there, kind of stuff. Okay. So based on that, you can enable more than one reduce task also. And cluster wise, in the Cloudera manager, the default reduce task is equal to sometimes we set it as 4 or something like that.
Okay.
Okay. So we can enable that at cluster level, and also we can control that in the MapReduce job. Okay, good that at least some of the guys tried and came up with answers for this. So that's why it took so long time. Even 9 minutes is not an acceptable time.
Yeah, I saw from Swaroop it took 34 minutes, but if it takes 34 minutes for 1 GB file, then there is no use of using Hadoop over RDBMS.
Even 1 GB is not acceptable when you compare with the RDBMS. Okay, RDBMS with 1 GB file, it comes within 30 seconds or less than a minute only.
Yeah, exactly. Yeah. Yeah, it's interesting. Mine took about 2 hours. Maybe I have 4 GB and maybe, I don't know.
Uh,
Hmm.
it's the same program. You didn't do any alterations like.
So what I did is I have a 1.13 GB, but all text file. I just took a 3 or 4 lines of text file,
Mhm,
then replicated that to make it a bigger file of 1 GB,
mhm.
and then use that to run the program. That's it. Exact same. Everything else is same.
Yeah, might be your VM is slow.
Yeah, I
And
think. Yeah, yeah.
okay, so two reasons why your programs took 9 minutes is you ran with only one reducer task, and even if you run multiple reducers, no,
Yeah, I've done with 3 reducers and it took somewhere around 4 minutes, I guess.
it with the same thing.
Yeah, no, I took 2 reducers and it took somewhere around 3.5 minutes or 4 minutes. I didn't
Actually,
screenshot.
even those reducers should have started sequentially because you will not have those many reduced left. By default,
Yeah.
in your quick start VMs, you will have at max of 2 map slots and one reduced left. If I have to show you in the configurations, I can show that as well. This is more of like just examining the job. Okay, I'm not explaining any concept.
And one more thing, Shiva, I've observed, like in the screenshot, like when I was running the MapReduce, that one map task got failed. What was the reason for that?
Uh, you only should tell me that because I can parse that log message. So what you should do for that is, so go to this URL. Okay.
Uh-huh.
So it will, if while the job is running, you can go to this URL, quickstart.cloudera8088. Once the job execution is completed, then you
Zero.
you should point to 19888. That is a job history server.
Okay, history server. Okay.
Once you go there, I have shown you how to launch that
See,
application.
I saw that log file, but I didn't understand what was wrong, so I just left it.
So it will throw some exception messages. What is wrong? So
Okay.
sometimes it might try to access the block, and that block might be busy.
Uh-huh.
And even after 3, 4 attempts, the block may not be available.
Yeah,
So
time out something.
yeah,
Yeah.
what I was telling you, right? So for every such operation, there will be 4 attempts. Even after 4 attempts, if it fails, then that task is marked as failed, and again
Okay.
the task will be relaunched on sometime later. I mean, given a some time pass break. So these all things we don't need to really take care of it. MapReduce framework itself will take care. So it
Okay.
will launch that, and if it succeeds, it will go and continue with that execution. Otherwise, even after that, if the map task got killed 4 times, then your job will be aborted.
Okay.
Okay, so yeah, if you have that in your machine, we can see that the log messages there.
Okay. Let me switch.
Okay. So the two reasons I was trying to say is, so you will have only one reduce slot enabled on your machines. So since I don't have anything, how many maps or how many reducers that I should run in my map reducer in my mapred site.xml file. Obviously, if I don't find any property, if I'm looking for a one property and if I don't find that in this, then I should look for the default files. Okay, and if I have to show you the default MapReduce mapred hyphen default.xml files. See, MapReduce.job.maps. For each job, the default number of tasks per job is 2. And the default number of reduced tasks per job. So default number of reducers, it runs only 1.
For job history server, it is
19888.
19888. Okay.
Yep. Okay.
One question, Shiva.
Yeah.
I mean, if our machine is, let's say, 8 GB of RAM, and if you configure more than 2 mappers, I mean, let's say 4 mappers, will all 4 can accommodate in that available
No,
RAM?
again, not. Here you will have a JVM options. See, for each of those tasks, it expects that much of memory and that much of JVM options to be available there. Let me show you those JVM options also. Yeah. So if you see here, MapReduce.map memory MB. So 1024 MB means 1 GB by default. And for every one map, it expects 1 virtual core CPU. And for reducer, you have 1 GB allocated for one reduce task. And CPU, 1 virtual core CPU is needed. So that means if you have 4 GB allocated to your this Cloudera Quickstart VM, if you are not using that 4 GB for any other tasks on your VM, you can max run 4 map tasks parallelly at a time. But you are already running all other tasks as well, right? Your data node services are running, and your Spark services, so many services are running here.
Shiva, I switched on to my log.
Okay. Oh, okay. Let me see into your logs. Okay. So if you observe here, there are so many services running along with the node manager, right? So even running all these processes will take some amount of RAM memory. And inside that node manager, once you start the map task, it expects this 1 GB to be available for that one map task. This is the default memory that these tasks expect, RAM memory. And it occupies 1 virtual core CPUs. And for my knowledge, you might not have allocated 2 virtual core CPUs for entire your VM. Okay. So even though you have 12 blocks on your HDFS file, so you didn't really achieve that parallel processing capacity on your clusters, because there is only one node manager running, and inside that map tasks will be running one after the other based on the RAM memory available in the system. And after the map tasks are completed, then reduced tasks will get picked up. Of course, a reduced task will follow after the map tasks only, even in the distributed cluster. But here, 12 map tasks, running the 12 map tasks sequentially means you're really not achieving the parallel processing when you're running on one single laptop.
Okay. Yeah, got that, Shiva. So let's say by default you have this number of mapper tasks are 2, right? So that is set as a default configuration.
That is just the default configuration per job.
Okay. Let's say I have enough hardware capacity where I can run more than 2 map jobs parallelly. Because of this configuration cap, will that hardware become unused?
No. Per job, this is for one job, at max two default two map tasks it can run. Okay, so default number of map tasks per job. But why in your case the data, even though for this MapReduce job it should run only 2 map tasks, but still it launched 12 map tasks. So I mean, to be more specific, and if I go much into deeper, there the map task configuration is just gets ignored. Like, so when you have more number of blocks or more number of input splits than the configuration that you see there, that will get overridden. So your default MapReduce.job.maps property, we didn't set anywhere. If you see, I don't have that property set anywhere. Name. Oh, I pasted it just now. It's wrong. Instead of pasting in the search box, I pasted there. Okay, so it's taking the default mappers, default number of map tasks and default number of reduced tasks. But to run Akila's job, 1.5 GB means for 1 GB you have 8 blocks, and again for another 500 MB you need 4 blocks. So total 12 blocks. 12 blocks, 12 map tasks. So it tried to run the 12 map tasks only, not just 2.
Okay.
Okay.
Got that, Shiva.
Coming to the map count, your input size is the final factor that derives it. And coming to the reducer, your input size is not the one which derives that. It is the configuration property that you either set here. So try changing, try putting this property inside your MapReduce.xml. So somewhere like this. By default, you will not be able to directly edit this file. You have to do it through sudo. Put that property here. Am I recording the session? I'm a bit okay. Yeah. So put that property here. So this is changing at cluster level. So make this as 4 and then run. Then you can see 4 part R files generated from your MapReduce job. You can see launched map.
If we change that in MapReduce.xml, then we can.
It applies for all the MapReduce jobs.
Yeah. Okay.
And after changing that in the MapReduce.xml file, you should restart your resource manager services, resource manager, and as well as manager. So how will you restart those services?
Start.
If you remember me? What? No, that is parcels installation.
Okay.
Sudo service, yarn, resource manager, start or restart. Similarly, sudo service, yarn, node manager, restart. These are the commands. I hope I explained these commands already. I remember.
So why do we have to do sudo here, Shiva?
Because as a regular user, Cloudera user, you don't have access to control those services. Those services are installed under a root account.
And by increasing the map, do you think our local our laptops with only one node manager,
Mhm.
you see the performance increase?
No, in your laptops, I don't see. I mean, we don't see any much performance improvement. There might be a little bit if there is a scope for RAM memory available to run two reduced tasks at parallelly. So here one more thing is, even if you specify here, you should run 4 reduced tasks parallelly for each of your MapReduce job. Let's assume in your cluster there is only 2 reduced slots available. Then only the first 2 will get run parallelly. Once after completion of them, then the next 2 will get kick-started.
Oh, got it.
Okay. So here the performance depends on 3 areas mainly. So the coding style, the coding efficiency is the first one, and your configuration properties in the cluster, and your infrastructure, hardware infrastructure. So that what does that mean by is, you should write your code efficiently instead of looping through the same record again and again, causing a lot of time consuming. And that is one property that we need to take care. This is in developer's hand, and this is by your admins. So they should specify the optimized configuration properties. So assume, like, since you have only 4 GB allocated to your quick start VM, so just running one reduced task is sufficient. So of course, when you have 256 GB RAMs and 256 GB RAMs, and out of this 256 GB RAM, they should allocate some 32 GB for your Linux, and plus some 32 GB or so for your HBase, and your assume that you are running your Impala also, and Impala needs a lot of in-memory. So let's assume some 64 GB or 96 GB for, or let's just assume 64 GB for your Impala, and remaining RAM memory allocated for YARN. Okay, so how much will be remaining? So 64, 128 GB. So remaining 128 GB is available for YARN. And keeping this in mind, in real-time clusters, will not keep this map size as 1 GB. Okay, so map memory MB as obviously will not keep this as 1 GB. And if you see here again, there is one more property. So MapRed child Java options. Child means it could be either map or reduce task. And inside this, for that entire map memory, for this entire map memory MB, the memory to request from the scheduler for each map task. Okay, and inside that JVM, just to run with task processes, it again, either you can control using these properties or these properties. Okay, so ideally speaking, these all things are needed for administrators. Okay, since you guys are asking me questions related to that, I'm just explaining here. So even if you don't understand, or don't worry about these things much.
Okay, one last question.
Yes, Amit.
The configuration you just spoke about, right? Splitting the memory.
Mm-hmm.
So let's say I have 4 machines in my cluster.
Mm-hmm.
So for each, this configuration is going to be consistent for all the machines.
Yep, they should be consistent across all the machines. Otherwise, some machines, if you allocate some tasks to some machines, they run faster, and the remaining machines will be running slower, and overall your job performance is affected. So assume you have 10 tasks and 9 tasks completed in just 10 seconds, and the 10th task, because of your inconsistent configuration, it took 2 minutes. Your overall job completion time is 2 minutes only, right?
Yeah, got it, Shiva.
Okay, so always your configurations across all the 10 machines should be consistent. That's the recommendation. Even if you don't give, it will run, but you will not get fruitness of parallel processing, the actual ideal parallel processing.
Siva,
Yes,
Siva, what about again? The coding efficiency is definitely a long topic.
Yep.
But any specific tips?
Any specific? Okay. So one example I can say is like, let's say if you are connecting to a database and reading a table, and generally the DB connections, we should put them in the setup methods, because that is one-time effort, right? DB connection, making a DB connection and reading through the run your query and read through those records inside the map method. So instead of that, by mistake, if we open the DB connection, or this is just one example, okay? So that doesn't mean that you will always write the DB connections in MapReduce programs. If you put that in map method, so for every input record, it tries to open a new DB connection to the database.
Yeah, that will be a disaster. The DB will come running.
Okay. Yeah. So that will hang your database itself. Okay. So that is developers in hand, and configuration properties. So based on this 128 GB RAM, so by keeping let's say in our default configurations, I have 1 GB per one map task, but in your real-time cluster, since you have a lot of RAM memory available and you have 24 core CPUs, which in turn means in a multi-threaded environment, so you will have 48 virtual cores. It will be double virtual cores. Okay, guys, whoever is not able to understand, don't worry these things. This is purely for admins. Purely for admins. Okay. And there are some calculation formulas that we follow. How many containers we should maintain in the cluster. So which should not be more than the number of cores is one rule out of them. There are many rules. Okay, I'm not talking all about them. So one of the rules that we have, it should not be more than your number of virtual cores. Let's say assume 48 containers. So for each container having one vCPU, and if you divide this 128 GB for these 48 containers, it might come around 2.5 GB, so, right? So 2.5 GB RAM and one virtual core CPU is the processing unit for one container. Then you obviously need to make this property changed to 2.5 GB around. And here also changing that property into the same value. So that means from next time onwards, whenever a map task is submitted, even if you are processing the smaller file, let's say 100 MB file, then it tries to, this is the maximum, okay? So the maximum size it can utilize. The minimum size also it will have around 200 MB or something. So based on the input size and it's required, so it can use up to 2.5 GB RAM. So this is the server level configurations. Generally, your developers will not have access to view these configuration files also. Since this is in your pseudo cluster and the entire laptop is in your hands, you are able to view these things. But in your real-time clusters, you'll not even be able to have access to these conf folders and you don't have access to your Cloudera manager also to see these properties. Okay, so this is an admin's hand, and how much ever the configuration this admin is doing, if there is not much capacity available with the hardware itself, you can't do anything. So even if you specify for each map task 10 GB, but if you don't have that 10 GB available for each map task, then you can't do anything. So this is in infrastructure teams.
Shiva, 48 containers means we have a capacity of running 48 tasks in parallel.
Yes, exactly. Okay, and don't ask me the rules behind this kind of coming out the containers count. It takes almost like a session. Okay, and how they come up with each data node storage capacity also. So generally they will come with this 256 GB RAMs and 24 core CPUs and 21 or 22 terabytes of hard disks. And these will be not just in one hard disk, they will have 22 disks also. All these number of disks, number of cores, number of GB RAMs, all things will come into picture while calculation of the how many nodes you should have in your cluster and how many containers you should have in your cluster and how many map slots per data node and how many reduced slots that you should have per data node. All these things will be considered into picture at the time of your cluster setup. Okay, so
more of capacity management, capacity planning.
What about?
Is it more of capacity planning?
Correct. Yep. So based on the data size that you are going to deal with, and based on the user requests that you are going to get, and so keeping all these things in mind, so these things will be derived. Okay. So this is very broader topic. So and it's purely decided by the infrastructure team and the admins team. And this is only one-time setup. Before the cluster is set up, they will take all these decisions and they will set up. And if they are not sufficient with this configuration, they can keep on adding such machines, 3 or 4 or 5. So based on the requirements. Okay. You don't need to worry about these things.
Siva, what processing capacity we are looking with this kind of configuration? Like how many of GB files it is
how many
expected to process?
files with this? Let's say with this configuration, let's assume I have 10 such nodes in the cluster. Okay, so I can easily process minimum of like even 5 GB file or 10 GB file. At least I can say up to 50 to 100 GB file, not more than 2 minutes. Even up to 100 GB file. 100, it could be one file or just multiple files. So up to 100 GB files, you can process within 2 minutes. What happens if we have new and old servers in the same cluster? So I took this example, right? If you have combination of both new and old servers, okay. So old servers in the sense the same configuration. If it's the same configuration, it doesn't matter. But old and new servers means that if the new servers are running faster and old servers are running slow, that means your all new servers, new 9 servers ran in 10 seconds, 9 tasks completed. If the old server is not running as fast as the new one, if it's taking 2 minutes to complete the 10th task, then obviously your overall performance will be affected. So your job will take 2 minutes. Okay. So there is a framework to avoid this scenario also, but even then it's a performance impact. So there is a concept that is available to overcome this scenario. How the load is distributed. See, the load will get distributed just by the data, where the data got distributed. So in wherever your data is spread across the data nodes, on the same data nodes, it tries to run the map tasks. And reduce tasks, the load distribution will be decided by your resource manager. Okay. So now let's get started with today's session. Yeah, we didn't even start today's topic. Yeah, we were discussing just your observations and how the real-time cases will be like. So infrastructure, how does it look like? And these things. Where all places performance can be improved. Okay. So yeah, if anyone is interested towards the admin stuff, so for them, I would recommend, or I would give as assignment, like, so going through these, all the 4 site.xml files, core, MapRed, yarn, HDFS, and this default.xml files thoroughly and understand each of these properties. Okay. So if you have any doubts in any of these properties, you can come back to me. I can help you out as much as I know. Okay.
Share one question before you can go to the next step is, are all the defaults stored in the MapRed_default.xml and that is stored in that conf directory?
Default files will not be present in conf directory. Only the site-specific files will be present in the conf directory.
Exactly. So where does the default go then?
Defaults will be present in your documentation share folders. Yeah, from there it will get picked up. By default, they will get loaded. You don't need to explicitly specify those files here.
I got it. Okay.
Okay.
So any changes
if you want to override any of those properties, just take that property.
Yeah.
Whatever the property that you want to override the default value, take this property, let's say IO sort MB memory is 100 MB. If you want to override that, take this property, put it in MapRed site.xml file.
Makes sense. Okay. Got it.
Site.xml file and override its value.
Yep. Got it. Okay. Nice.
So yeah, so this is, yeah, let me get started with today's topics. I didn't even start the slides today. So let me see if I have this. Oh, good that I have this job in the console itself. Okay, I don't need to rerun this again. So now I want to explain you the MapReduce job execution flow, yarn job anatomy. Okay. So I'm left with only 1 hour for today's session. Let me. So we have seen these demos, all these slides. We have talked about implementation of mapper, implementation of reducer. This is the test code and word called job. Yep. Now let's see the yarn job anatomy. How does the backend, how does your job get submitted? Okay. So inside the map task, inside the reduce task, we have written the logic. And when you submit from the terminal, so what all steps it goes before it gets submitted. So you are submitting the job, client submits the MapReduce job, and the resource manager controls the use of resources across the Hadoop cluster. And node manager is the one actually runs on each node in the cluster, creates execution containers, and inside those containers, this task will get triggered. And MapReduce application master, it is the one which coordinates with your resource manager and as well as your node manager to negotiate with resource manager and getting the enough resources for running your job. Okay, and also it monitors the tasks started by the node managers. And HDFS is the one which stores your input files and as well as your job artifacts between YARN components. So this is the list of components that gets involved in the YARN job execution. Just the list of components. I didn't explain you the flow. Now coming to the flow, this is, let's assume this is my client machine and I have written my MapReduce program and I made this as job. I compiled and prepared a jar and running this job. And this job will get submitted to resource manager. And you can see here, in the very beginning, it's connecting to the resource manager. And resource manager runs on 8032 port number. And this 0000 means it's on the same machine in which this is running. So since this is a pseudo cluster, you will see all zeros here, but in your real clusters, you will see the IP address of your resource manager, actual resource manager. Okay, but the port number will remain same, 8032. So the first step it is doing is it's connecting to the resource manager and it gets the job ID. Okay, and it gets the job ID and it copies the job resources. So here there are some warning messages related to the job and how many total input paths it should process, and it knows the job ID here. Again, there is a pattern behind this, how it derives this job name also. Okay, so this much of low level detail, sometimes even if you don't capture, I don't mind. So this is the timestamp at which your resource manager is restarted. A resource manager is started. This is the epoch format timestamp. Job underscore the timestamp under which your resource manager is started. From there onwards, what is your job ID? From there onwards, it will give the job IDs as 0000, 4 zeros, and next job is 301, and next job sequentially incremented 001. And when you restart resource manager after 1 week, again, that whenever you restart your resource manager, that time, whatever the time is, that timestamp will converted into this epoch format, one long integer, and again your sequence will start from 4 zeros. Okay, so this is how your resource manager determines the job ID, and it determines that job ID and gives that back to the client. And so whatever the steps, that some of the steps might not be visible in this messages. So once it gets the job ID, it copies the job resources. Now here, what are the job resources here? If you see here, yarn jar is a command. mr.jar is the jar file. And this is local to your machine. I hope everybody is following up and concentrating, because these are some internal concepts. Unless until you pay much closer attention, you will not be able to catch these things. Okay, so that mr.jar file is present in your local file system, in your home directory of your Linux. It's not present in your HDFS. So since this is your pseudo cluster, there is only one node manager. What about if you have 10 node cluster? Then how will it run that map task if that is not having that logic inside it? So even the 10th node has to run this map task. how can it run that map task if that is not having its own copy of the logic? So how will it get that logic? So from whichever machine you are running this command, so that acts like a client, right? And that machine uploads this mr.jar file from your local disk to HDFS location. And into which HDFS location? You don't really need to worry about these things, but let me show you. Into the temp HDFS temp directories, Hadoop fs-ls/temp. Okay, you can see Hadoop yarn, and if you take this Hadoop yarn, Hadoop fs-ls-r, you can see this yesterday 2016-06, if I'm not wrong, and this is the one, the job ID which I'm looking here, right? So 38469_0001. Let's see, 38461_0001. And word count, job history information is stored. So after the job has successfully completed, only the job history information is being maintained here. But while the job is running, it stores the jar file also under these directories. You can see here, job staging and the job IDs. So under these directories, even the job configuration and history done intermediate files, all this. So you don't really need these exact locations, but for your idea, so it stores that into temporary HDFS locations. So this client machine uploads that jar file into this location, and remaining 9 node machines, node managers, will download from this HDFS location into their local file system. Or they can directly read it from the HDFS itself. So that is the copy of your job resources. And here in this example, we are only the jar file will get copied. If there are any other dependency jars, or there is some dependency input file which needs to be available in all the machines, but that is local to your local machine. Here we have one HDFS file as input, but there is cases where you might need to feed 2 files, and one file might be from HDFS, one file might be your local file system. So that concept we'll see in our distributed caching mechanism.
Shiva, here the number of splits is 1. That means only one map task.
I will come to that as well. I will come to that as well in the flow. Okay.
Okay.
So first, any job resources, the dependent job resources will get copied onto your HDFS directories, no matter whether it's a temp or whatever. Don't worry about that. So your HDFS directories. So what all will be the job resources? Your jar files, any dependent archives, or any dependent input files. Okay. So next, what it will do is, so since you submitted this resource manager, your resource manager will identify one node manager on which there are some containers available. On that node manager, it will start this container, and inside that container, the first task that will get launched is MR App Master, which is MapReduce Application Master. So this is the point of contact for client from now onwards. I didn't show that line here, but yeah, this is the point of contact from next time. And now this MR App Master will evaluate your input directory and see, it observes how many input files are there in that directory. And how many, if there is only one file, and if that file is 1 GB or 2 GB, how many blocks it can be split into. Obviously, if it is 1 GB file, at the time of storing itself, it could have 8 blocks divided. And based on those blocks and your input split size, ideally speaking, the number of blocks and the number of input splits may not be equal always. There are scenarios, but that is first learn the ABCs, then we'll learn the advanced stuff. Okay. So for your easy understanding, the number of blocks the file is having will be equal to the number of input splits. Let's say if you have 1 GB file, 8 blocks it will get split into. That means 8 input splits. So your MR App Master reads the input directory size if it comes to know that it is 1 GB, and it decides that as 8 input splits. And based on that, now it knows that it has 8 input splits, and it knows that for running 8 input splits, it needs 8 map tasks. So for 8 map tasks, obviously it can't run all those 8 map tasks on the same node manager. So now it has no clues where to run those 8 map tasks. Now whom to contact? Obviously the master. It will place a request, boss, I need to run 8 map tasks. Tell me where should I run. Then resource manager again checks the remaining node managers which are free. It picks randomly whoever are free and allocates them. So these resources are free to run your map tasks. And it sends that list back here. Okay, so I didn't add too many arrows here because that might make it come clumsy. So that's why, so some of the missing arrows that I'm explaining manually here. Okay. So that the list of node managers addresses will be sent back to MR App Master. So now it knows that in which node managers it should start those containers. Okay. So then it will go ahead and start the containers on those node managers. So inside container, the JVM tasks, yarn chains will get kickstarted. Inside this yarn child, you will have either map task or reduce task. So this will actually get the jar file copied onto this machine. So now here in this 4th step, we uploaded that mr.jar into HDFS, right? Now that mr.jar will get copied to this node manager by this task in the 10th step. Retrieve the job resources and spawn the map or reduce task. And coming to the progress monitoring part of MR App Master, now map task will send the progress update for every 10 seconds to MR App Master, and similarly all the node managers. So let's assume you have 9 more node managers here parallelly. So from all those node managers, it will receive the map completed percentage, and it will aggregate that percentage here and it prints that aggregated percentage on the console to the client. It sends that aggregated percentages back to client, and on client machine, those things will get printed. Okay, too much of chaining. Here it should send the request to resource manager. It assigns the job ID. It copies the resources to here, and it launches the node manager to run the MR application master, and it identifies the size of your input directory, and it comes to know how many maps it should run based on that, how many maps and how many reducers it should run based on your cluster properties and as well as your input size. And it requests those many resources from the resource manager, and it sends that list back, and it launches the containers on those node managers, and those node managers yarn chains will go to HDFS and get the appropriate job resources and then spawn the map and reduce tasks. And once these tasks are started, these will keep on reporting to our MR app master how much percentage the map task is completed. This is completed 50%, the next one is completed 40%, the next one is completed 60%. Then on an average, it calculates the average of that percentage completion, and that average will be printed back to your client. And once after all the map tasks or reduced tasks are completed, then it prints the status back to 100% completion, and this MR app master will get killed. This will get killed, and again these tasks will get killed. Of course, these will get killed first, and then MR app master will get killed, and then finally you will have your status back to your client and resource manager. Is it clear? Or did I go a little bit faster?
No, clear, Shiva. This is good stuff. Thanks.
Yes.
Shiva, one question.
Yes.
When MR map master, assume it's required 10 containers to perform the job. Resource manager could not find 10, and it the 8 containers. So
obviously it has to adjust with that. It will run the 8 first and remaining 2 later after completion of the 8.
Or does it wait in the queue?
Yeah, it will wait in the queue. See, MR app master needs 10, but resource manager gave only 8. Then it will launch 8 first, and remaining 2 will be in queue. And out of the running 8 containers, if 2 of them are completed, then in those 2 completed containers, it runs the remaining 2 tasks.
Okay, let's say at that stage, a resource manager can find only 8 containers. And after some time, there are other containers are free. Will that unused containers going to be part of the execution?
No. Again, it will not make the request. Those will be utilized for the next jobs that will be submitted.
Okay, whatever the capacity get from the resource manager, that is the final.
There is again a broader topic, again specific to your administrators, that is the scheduling algorithm. Okay, so in scheduling algorithm, what will happen is there are 2 types of algorithms: first in, first out algorithm, capacity scheduler. Again, so I try to not to go into these topics because developers will get confused all these things.
Okay, that's fine, Shiva. Then we can conclude here.
Preemption, capacity scheduler with preemption option. So what does this mean by is, let's say, let me at least tell you this preemption option. Force preemption or free preemption options. What does this mean by is, if your cluster is running and if your job is taking all the resources and all of a sudden new job is submitted, there are no containers pending for that job, then what your resource manager will do is it will take 10% or 20% of the running job itself. Boss, there is one more new job waiting in the cluster. Since there were no jobs in the queue, I gave you all the resources, but there are some guys waiting in the queue. So can you give me 10 containers back? Then it takes those 10 containers and it assigns to the new job that has arrived. If that is the case, then it will always tries to allocate your resource manager as and when new containers are freed up, then it can allocate those containers also to the existing running jobs also. Phase scheduler and capacity scheduler, first in first out scheduler. But this first in first out scheduler is no longer we are using these days, but the capacity scheduler and as well as phase scheduler.
The default is capacity, I think, right?
Yeah, default is the capacity scheduler.
Yeah.
Okay. And if anyone interested in the admin topics and going through the deeper topics of these things, I would recommend just go through this Cloudera's documentation on this and come back to me if you have any questions on that. Okay. So one good thing is, see, distributed parallel processing means there are a lot of scenarios that can happen where you have your MR app master and lot of containers available, but sometimes some network issues and sometimes some other issues. So scenarios wise, you will face a lot of things, but ideal typical flow will be something like this. Am I confusing you guys or?
Siva, what about Yarn child? I did not get that part. Where does
Yarn child is nothing but a JVM task. Your JVM.
Oh, okay.
So this inside this child, you will run map or reduce task. Inside a JVM, this Java task can run, right?
Okay. But that's all part of node manager only.
All part of node manager and also inside the container only.
Yeah, and then you have a separate node manager here, number 6 launch.
This is for application master running, MR app master.
Okay, that is MR.
I think there will be only one app master, right?
For one job.
One job, right? Yeah.
If you have 100 jobs parallelly running on your cluster, obviously there will be 100 application masters.
Sure.
Okay. I want to spend even 5 more minutes also if you have any questions on this slide, because this is one of the important topic you should understand.
Yeah. Going back to the Yarn child, it's a simple process, right? Which keeps on, which spawns other processes inside that, right?
Exactly. Yes. So it's nothing but a JVM task. That's it.
Yeah.
One Java task. That's it.
Yeah.
Okay. So you can give a even more deep dive into any of these details, like what are other duties of MR app master and what is Uber tasks and this stuff also. I will leave this line. I'm not going to explain you, but I will leave this as assignment for you till tomorrow. If you can't find the answer for this, come back to me tomorrow. I will explain. Okay. So now in that process flow, you can see these messages. First, it connected to resource manager, then copying the jar into HDFS and resourcing on and requesting on which machine it should run the MR app master. Those two things happened in the backend itself. We don't have any information messages printed for that. Now, MR app master identified how many input paths to process. So there is only one file, and that too having only one block. So that means this tells how many files. Okay, total input paths to process. This tells how many files there are, and out of those files, how many splits. So there is only one file, and that is also of one block. So that means only one split. And so that application, you can track the progress. The application is submitted on that node manager. Okay. So now the job is running. Your MR app master is capturing the percentages of the map task and the use task, and it's sending that back to your client. Okay. Now coming to these counters. So mainly we'll have 3 or 4 categories of counters. Okay. So the file system counters will tell us, this is also one of the important area that you should focus on. So in the file system counters, it will give you how many bytes you read, how many bytes you written, both from the LFS and as well as HDFS. So if you see here, HDFS, number of bytes read, 260 bytes it read from the HDFS file. And what is my input file? So my input file is this one.
Hey Shiva, you have specified the HDFS part, right? Then why LFS came into picture?
That is my question to you guys.
So the output of the MR process?
Exactly. Good catch. Output of your map tasks.
Yeah, map task. Sorry.
Map
The
tasks
intermediate
get
data?
written into your local files, right?
The intermediate data?
Yes, intermediate data. Okay. And yeah, some temporary results they will write into local files and those things. Okay. See HDFS.
How do you make a sense out of it though? If it says file number of bytes read is 299, what do we infer from this number?
For local file system, you might not generally, we'll just see this whether the intermediate files got created or not, that's it. Okay, so whether they got written or not, from that, again, the intermediate data is read by the registers or not. So this much of information we'll get. The exact statistics debugging from bytes is I mean, in my opinion, it's not possible. Okay.
Yeah.
At least you will get what are the phases that are successful. Okay, but here the number of bytes read and number of bytes written, so sometimes will be closer to the input data that you have given, and there are some counters which will be more closer to you. So if you see here, file input format counters, again, this is the general total. So earlier we were not having these two sections at all. Okay, so these two sections were not there at all earlier, but now we see these as well. So along with the above file system counters, if you see here, exactly they are matching. File input format counters, bytes read, 137 bytes. And if you see here, for in your input file, so how many bytes are there? 137.
Yeah.
And if you see your output file, where is the file part R file? it is of 155 bytes, and the same you can see the bytes written here.
Yeah, I remember seeing this one. Yeah, thanks.
Okay. And also here also you should find them. So number of bytes written is 155. Okay, so this total number of bytes read from HDFS, not just your input file. So there might be some other extra bytes that it might have read. So that's why that 137 plus some other extra bytes resulted in total 260 bytes read from the HDFS. It could be your MapReduce jar bytes also. Okay. Now, so if you see under the job counters, how many map tasks launched equal to 1, launched reduced tasks equal to 1, and if there are any killed map tasks, those were also printed in Akila's execution screenshots. Okay, so data local map tasks, what does this mean by keyword? I was highlighting this. Data locality optimization. Running your map task on the same node manager where your block is present. That is called data local map task.
So if it is not really local, what value do you see here? Let's say I could have.
See, if I have total 10 map tasks launched, assume, okay.
Yeah.
And let me take this time the help of Paint or something. Just give me a few more seconds. Okay, let's assume I have this one node here. I will draw only few. Okay, another node here, another node here. Okay, I will explain you this scenario. Please pay careful attention. Like here I have two map slots available. Okay, so two map slots available. Here one map slot available. Sorry, two map slots and one reduced slot. And similarly, two map slots and one reduced slot. So total 6 map tasks are available on your cluster, and 3 reduced slots are available. So parallelly, at max, as per your hardware configuration, you can run 6 map tasks at a time on your cluster, and 3 reduced tasks run at a time in the cluster. Now, you have received a file, one input file, that is having one block in this and another block in this. So 2 blocks are there for that file. And by some reason, your resource manager already allocated these 2 map tasks to some other job. Already there was job J1 was running, and that took these 2 map slots, because for that job 2 blocks are present in this. So those 2 blocks are being processed by this. Those are called data local map tasks. Now you submitted the second job J2, which has to process this block, which has to process one input file. So that input file is having one block here and another block here. And in this, 2 map slots are available. Both the map slots are available. It can run 2 map tasks on this machine only. Now, one map task can read this block, which is data local map task, and the second block is available on this machine. Let's assume not even the replications are available in this machine, but you have map slot available. You can run the map task, but you don't have the data available, that block available in this machine. Then obviously you don't have option. You
transfer the data.
Yep. Transfer this data and run this map task. Now, is this map task local to the data? No.
Yeah, no, yeah.
Okay, this is, again, one of the advanced topic. The rare scenarios. Okay, ideal scenarios, general Hadoop terminology, the scenarios are like your map task will run on the same node, the blocks present on that same node. Here, the map task will run on the same blocks that are present on the same node.
So data is not copied to that where the map is running, is it?
Data will get copied. If your map task is available here, but data is not available here, and then ideally instead of waiting for this machine to complete, it copies that block to here and it runs that.
But for the reducer, it may be always a data might be transferred to a different node, right?
Yeah.
The reducer will be always
the reducer is running on this machine, and if this map output generates some local output here, and this generates some local output, and if your reducer task is running here, this will get copied to there, and this will get copied to there.
Yeah, yeah.
Okay, so that's why you have that separate one more counter for data local map tasks. Ideally, if this count is equal to this count, that means your job run. It's ideally getting the distributed parallel processing. You have achieved the data locality optimization.
So the resource manager, while finding out the resources, will keep all these things in mind.
Yep. It will check all these things in mind. Yep. So from where does resource manager gets the locations of these blocks?
From the name node?
Name node.
Yep. So total time spent by all maps in occupied slots, this much of milliseconds, reduces this much of milliseconds. You can trace these seconds to identify which is the section that is taking a lot of time, and you can concentrate on that. Whether map phase taking a lot of time or reduce phase taking a lot of time. If that's the case, why and how you can improve. This is all for tracing them back. Okay. So you see all these things. How many map input records? Inside your input file, how many records are there? This is one of the important factor for considering in your unit tests and as well as your testing purposes. For your QA people, mostly this section counters is useful for testers, big data testers. If a MapReduce job is run, whether the job is running fine or not. So whether you have optimally specified the tasks or reduced tasks, and whether your MapReduce job is completely processing all the input records or not. How many input records it processed, how many records it produced, and how many bytes produced from there, and how many input split bytes, and how many. So whatever map output records, the number of records that came out from the mapper should be equal to the number of records that you are feeding to the reducer. Reduce input records 26 and reduce output records 20. Okay. So don't worry about this build records, these things. I'll leave this for you to explore. Shuffled maps. So once after the map outputs are generated, that shuffling phase will come into picture, right? So how many maps are there? Those many map outputs will get shuffled. Okay. Some of these things. And any errors during the shuffle, they will be reported here. And these two types of counters we have already seen. So is it clear? Does this make sense? How to debug your messages? How to understand your messages?
Yeah.
Okay. Yeah, thanks a lot. This is one of the critical session, I can say. Okay. So can we configure the input split based on our hardware configurations? Yes, we can, but I will tell you that sometime later. Because if I put so much of advanced topics, if I go deeper into one single topic, you'll feel it like complex. Let me go on at least 100 feet level or at least 50th feet level, then we'll go if needed. Okay. And up to my perception, like in this stage in the industry, this much of depth in MapReduce is enough, more than enough. Okay, because these days no one is going towards the MapReduce coding. Okay, so if you learn the coming tools, Pig, Hive, Impala, all those things, you will understand the reason why industry trending towards that, or Spark. Okay. So this is the same narration that is written in the text here. So client submits the MapReduce job by interacting with the job objects. Client runs in its own JVM. So MapReduce job class to configure the job. And this is the statement which submits the job. And in the MapReduce.xml, by looking at the MapReduce framework.name as yarn, it identifies that it is a yarn framework and it submits that to resource manager. Jobs code interacts with resource manager. Okay, and moves all the job related resources to HDFS. Okay, go through this text. So this is MapReduce version 2 architecture. The right side part of it. Yarn, resource manager, node managers. Inside that node managers, containers will be running, and containers, inside the containers, there can be MR app masters running if there is an active job run. Okay. So this MR app master will be active during only your job run. And in only some of them, MR app master will run, and then the other things, it will run the map or reduce tasks. This is just for the right side portion. I put this slide again.
One question, Shiva.
Yeah.
On the previous slide.
Yeah.
See, some of the blocks you named as a node manager and some of them are data nodes.
They both are same. This is same. This is one slave machine. 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 I was repeating the same point so many times. This is one slave machine. Since this is under yarn framework, I put this on top, this one on the bottom. This is under HDFS. I put this on the top and this. See, you will not have these two slices. Just to represent here, I separated this HDFS components on left side and yarn components on right side. Coming to the slave machines, they all will have, all the slave services will be running on one single machine. Node manager, data node, and any other, all other slaves services will be running on the same slave node, and same case here.
Node manager concept come into picture when you are trying to launch application master, is it?
application master and as well as your map task or reduce task. Node manager is nothing but your slave for resource manager. Same like data node for your name.
Okay, got it.
I think you missed the initial few sessions, Ramesh. That's the reason.
I'm sorry. That's okay. Yeah, sorry.
Okay. Okay. So if you are clear so far, then let's discuss the failure scenarios that can happen. And so we have seen this much of flow there. So it can have, the failures can happen in any stage. Okay, so let's take the lowest level of failure scenario. That's the at task level. This is the lowest level of execution. So let's assume a map task, while running the map task or reduce task, this got failed. One second. So if that task gets failed, and next level it can fail is the node manager failed, and the next level application master is failed, and the next level resource manager is failed. Okay. So initially the lowest level, if you take, this is the most likely offender, and most of the times you see these failures. Task failures might be because the block is busy, might the network is busy, or the sometimes that the file being used by some other job, and timeout exception, memory exception for one such task. Okay, so this is a most likely offender one. So tasks, exceptions, and JVM crashes are propagated to MR application master. If that task is failed, so this task is failed. So that information will be propagated to MR app master by your yarn child. Now, your MR app master will mark in its book as like, so and so map task got failed once. So one attempt is marked as failed. And again, it will reattempt on the same. It will restart the same task on the same node manager and the same JVM. Okay. So it tries up to 4 attempts. Task is considered to be failed after 4 attempts. And this is a configurable number. Set for map task via MapReduce.map.max attempts. And set for reduce task via MapReduce.reduce.max attempts. Okay. And hanging tasks will be noticed by MapReduce.task.timeout property. Attempt is marked as failed. Suppose there is a task, map task, and that is waiting for a block to be available. But that block is not available even for last 20 seconds or 30 seconds. So this is, you see the default property value for this. Okay. So how much ever seconds that are configured. So even after that seconds, if it is not getting the resources, or if it is not getting executed, or if it is not showing any progress, if it is 0% some 30 seconds back, and even after 30 seconds, if it is still in the 0% progression, then that means that task got hanged. And your MR application master identifies this task as hanged, and it will mark that as once the timeout is reached, that task will be failed, and again it will restart the same task on the same machine up to 4 times. And after 4 attempts, that task is failed, that is failed. And if that task is failed, and it will try to launch that task on another node manager where it can find the second copy of the same block. That's why even if one of your tasks is failed or killed, it launched another 13th map task in your scenarios. We have seen that PDF, right? Okay. If 12th task itself is, if 12th task itself after one attempt or two attempts, if it got succeeded, then you might not have seen the 13th task getting launched. If one task failed 4 times, means it tried to run on again another. So here in our case, so there might be some timeout or due to some issues. It might be some other issue. It might not be the block issue. Okay. So that's why, because you have only one data node and there is no chance that it can run on another machine. Okay. So there might be some timeout issue or some other network issue or something. So that one task got failed and it launched the task once again. Now that is the lowest level failure, and if it gets failed, and it will be relaunched. The next thing is if that entire node manager goes down, or okay, the entire node manager goes down. If the node manager goes down, failed node manager will not send the heartbeat messages to resource manager. First one, your resource manager will come to know that this node manager is failed, and also your MR app master will also come to know that if it is not receiving the percentage progression of your map or reduced task started on that node manager, obviously even that will come to know. Okay. So either of these two identifies that the node manager is failed. Okay. Now, resource manager will blacklist that node manager so that this is failed, and it will allocate another active node manager to the MR app master, and on that your application master again relaunches those tasks. Okay. Now, yeah, generally the wait period for node manager to send the heartbeat messages before it blocks as a dead node manager is the 10 minutes. Now the node manager failed. Node manager is not failed, but the MR application master itself is failed. This is the coordination component, right? So for a particular job, if this failed, and by default, it will not be restarted. If it's failed, the job will fail, but we can enable the restarts on that, automatic restarts on that MR application master by this property. Okay, so yarn resource manager dot am means application master dot max hyphen retries. If you set at least 2 for this property, if MR application master is failed, then again your resource manager starts that MR application master on the same machine. Resource manager receives heartbeats from MR app master and can restart in case of failures. Restarted MR app master can recover the latest state of the task. Completed tasks will not need to be rerun. And how can you enable that recovery? By making this property to true. Otherwise, it will not be able to recover that state, and it will rerun even the completed tasks as well. So this is the default property that comes by true, and admins will make sure that this will be always true.
Shiva, Shiva, in the start, in couple of sessions, we had come across that point where the job will fail, suppose 500, and it will fail at 251. So is this property which drives that?
Yep.
Okay.
So now, if that MR app master failed at 250, copying the 250 bytes or something, I mean processing 250 bytes, and if your yarn resource manager, by finding this property more than one, it will try to reattempt the MR app master, restart the MR app master these many times that we specify here. Now, from there onwards, if this recoverable status is enabled, exactly from that status, it continues. See, your MR app master is failed, but not the tasks, right? See, in this, now MR app master is failed, but all our node managers which are running the map on reduced task, where the actual processing is happening, these are running fine. Now this is failed, again this will come and restart this. Now this map sends us that I am completed 80%, I am completed 60%, and some other map task come with I am completed 70%, and then aggregates this again once again and sends that back.
So there would be a lot of failures, is that right?
There can be a lot of failures that can happen in this scenario.
Oh.
So these many chains means a chain can be broken at any link, right? If you have a lot of links means there is a lot of chance for failure also. Your chain can fail broken at any link. But your framework is such a reliable one and efficient one so that it can handle automatically all these scenarios.
So if it fails, then now the MR app master, that will restart it from.
If MR app master is failed, your resource manager again will restart this MR app master on this node manager.
But your map and reduce, that will still continue.
Yeah, they will still be continuing.
That is irrelevant. Okay.
Irrelevant.
Okay.
Now, if this map task is failed for 4 times, now your MR app master will start the map task on another node manager. So if this is the failure, and if this is the failure, this is irrelevant, right? Again, it can get restarted once again by the resource manager.
Okay, got it. Perfect.
Okay.
Thank you.
Yep. And now this is the lowest level failure, and the next failure is node manager failed. If node manager is failed, this entire node manager is failed, this map and reduce task will be launched on another node manager by your MR app master. So that second scenario we have seen. And third scenario, failing the MR app master itself. Now that also we have seen what will be taken care by resource manager. Again restart. Now we have seen the failures in this area. Now, if there is a risk for the big master, the big head, resource manager, then it's a severe failure to the cluster. Your cluster is completely down. You can't run any of your MapReduce jobs. And mostly, we can enable a recovery of what were the tasks that were running, but node manager blacklisted by MR app master. Even MR app master can blacklist the node managers on whichever the tasks are failed. By default, blacklisting happens after 3 failures on the same node. So resource manager failed. This is the most serious failure. That means your cluster is downtime. Jobs or tasks cannot be launched. And resource manager was designed to automatically recover an incomplete implementation at this point of time, and still the implementations are going around to make it high available instead of single point of failure for yarn framework on Zookeeper based implementation. Okay, so this is a broader topic. I will again relate this point while I discuss about Zookeeper in HBase. How does using the Zookeeper, how can we make high available? If that is not there, how your resource manager became the single point of failure. Okay. So there is one more topic related to these failure scenarios, which is called speculative execution. Let's say when the task is failed, when I was showing you that, right? One map task is failed on one node manager and it re-attempted 4 times on the same machine. If it's failed, it's failed. Then it launches the same map task on another node manager where it can find the second copy of the block. So that concept is called as speculative execution. Speculative execution will spawn a speculative task, one extra task, when all the tasks have been started and task has been running for an extended period of time over a minute, did not make significant progress as compared to the rest of the running tasks. Either your task is not making significant progress when compared to other tasks, or your task is failed, or your task is killed, or your task is hanged. In all these 4 scenarios, it spawns a speculative task on another machine. This example I was giving you, right? Here, 9 tasks completed in 10 seconds, and the 10th task is taking 2 minutes. In this scenario, if you enable the speculative execution, after completion of 10 seconds or so, if it's still at 20% completion, so 9 tasks are completed 100%, but still if this task is at 20%, then if we enable the speculative execution, your Amar App Master will spawn this 10th task also in one of these 9 nodes. One more copy of it. So now 10th task is running, assume 10th one is running on 9th node as well. Okay. So 10th task is running on 9th node and as well as 10th node. If whichever runs faster, let's assume 9th node completed faster. So 9th node reached 100% after just the 20 seconds. Okay. Now, even after that, your 10th node, your 10th task running on the 10th node, still at 40%. Then, so this task will be killed and output from this 10th task ran on the 9th node will be captured and will be combined into the final result. This concept is called speculative execution. In interviews, they might ask you this keyword. Something catchy. Okay. So by default, this property will be enabled in your cluster, but this percentage of speculative execution, this is again another important topic for administrators, and ideally they should not make 10% of the task to be speculated. Let's assume this property, speculative execution, should not result into some weird scenarios like if you have 10 tasks, at max 1 task can be spawned. Okay, so 10%. If you have 100 tasks, at max 10 tasks can be spawned. Otherwise, if you allow more percentage, that means if you have 10 tasks, 100 tasks running, if after 1 minute or 2 minutes, if you see 50 tasks are running slow, then if you relaunch 50 tasks parallelly again on another machine, so that means you are running 150 tasks for a 100 task job. That means you are heavily utilizing the resources for one job itself. So to avoid such scenarios, so we limit that percentage of tasks that can be speculated, that can be spanned, is max of 10%. Or in some cases, they might turn off also this feature. Okay, but I don't recommend that completely turning off this. Just turn it on, but make the percentage lower. I hope you catch the difference. Okay, next job scheduling word count example. MR unit and combiners. This stuff I will take it up tomorrow's session. Okay.
Shiva, one question on the previous slide.
Yes, sir.
You said 10% should be, I mean, if you set as 10% for the speculation execution, so that means out of 10 machines?
No, not out of 10 machines. It by tasks, number of tasks for the job.
Okay. 10 tasks, one task is slower than others.
At max, one task can be spanned at any time. So let's assume if it is 10% and my job is having, job J1 is running with 10 tasks, okay, with 10 tasks, but 8 are running faster. 8 are running faster, but 2 are very slow. Even then, only one will get spanned. Only at any point of time, for a 10 task job, you can run max of 11 tasks. So these 8 running faster. So one is running now, one is spanned. Now it became 10. So once after these 8 are completed, then you may span this second one also. Now 4 tasks running parallelly. But while these 8 are running, at max you can make 11. This fast running 8 tasks and 2 slow tasks and 1 again launched on the fast running machines.
So how do we determine the slowness of the system task?
We don't need to determine, and we don't need to take care of any of these things. Just setting this property to true, your MapReduce will take care of that stuff. You don't need to worry about it. That's the best part.
Oh, okay.
You don't need to deal with these things. This is one of the optimization property. Just setting this property is enough for you. It determines it. It takes the average progression percentage from each of the node managers.
All right, sure, I got it. Yeah.
Okay. Any other questions? I know we are going slowly into deeper concepts.
One question, Shiva. Neetu here.
Yeah. Yes, Neetu.
As far as I have understood till now, most of the things are taken care of by the administrator, how he set the properties.
Yep.
Any job, or at the machine level, it is taken care of by the
framework. By the framework. Yep.
So, as a developer, we only write the mapper jobs, run them, and then look at the log. And if there is any failure,
yep.
So who do we approach, or we don't even need to approach?
It's a cluster issue. Like if you're not getting enough memory, if your job is failing with out of memory exceptions, or if your job is failing with permission issues, if your job is failing because so and so dependency is not there, you should shoot an email to admin team. If other than that, If your job is failing some null pointer exceptions and some kind of exceptions that is due to bad written code, then it is our responsibility to resolve those issues.
Okay. Okay. That's why we need to know about all the properties.
Yesterday's session is more towards the developer, and today's session, the initial first 1 hour is purely for administrators, that whatever we discussed, configurations and optimizing your cluster. And even after that, so whatever we discussed is purely handled by your framework. Your yarn, job flow, and failure scenarios, and the speculative execution. All these concepts will be handled by your framework itself. That's the best part of it. You don't need to worry about it.
Okay.
Yeah. Slowly we are going into the deeper concepts of these things, but I don't want people to go silent. So please keep asking the questions more and more. Try to understand more and more in the session itself. So don't hesitate, guys. I mean, I sometimes I observe some people, they will have questions, but sometime later they will come to me. I feel like if they could have answered, I mean, if they could have got the answers, they might have better understood the subsequent classes. Don't hesitate in asking the questions. Okay, I'm okay to spend time on the same topic again and again. But at least whoever are coming from non-Java background, for the initial, during the learning period, MapReduce, take it as a framework and just understand the concepts that it can do, and understand the word count program. That much enough. And anything advanced, we'll see that later. Okay, you can come back to that as a second revision. Advanced programming. Other than that, at least first understand the topics. You should understand what is MR App Master, what is Job History Server, what is Resource Manager, what is Map Task, what is Reduce Task, what is Speculative Execution. So what will happen if a job is failed? Where should you look for the logs? These stuff. Okay, so these are common for all the jobs, any MapReduce program that you write. So that's why first understand the common features first, and understand the word count example, because it is having 2 lines in mapper class and 2 lines in reducer class. That's it. And remaining all other lines are common for any MapReduce program. And driver program is common for any MapReduce program. It's the same. At max 2 or 3 lines of code might get added.
Ishia, one question that comes to my mind is, you know, when we mentioned or talked about the map logic, the key was the file, I mean the offset or something.
Yep.
But what if the file is not a text file? Do we actually give the key?
What if it is not a text file?
Yeah.
Good question, but I will answer this later.
Okay.
Okay.
Yeah, sure.
We are going to discuss the file formats as well. So at that time we'll discuss this.
Yeah, got it. Yeah.
Okay. Yep.
Bashir, thanks for all your help. You are doing a fantastic job in explaining complex subjects in a very simple way, which is very, very good. Thanks so much.
Thanks, Lakshman. Okay. Thank you very much. Bye-bye. Okay, let's meet at the same time tomorrow. Same time. Yep. Bye-bye.
Shiva, you said like you'll see my log file.
I have something to catch up immediately. I'm getting some quick calls on my mobile. I will see sometime later. We'll see this. Okay, no worries. Keep running more jobs and you'll see more tasks failing. Then we can trace. Not a problem. Okay.
Okay, no problem.
Okay.
Thank you.
Yeah.
Bye.